definite integrals. Definite integral as the limit of a sum. Let y equals to fx be a continuous function defined on the closed interval a comma b. Assume that all the values taken by the function are non-negative, so the graph of the function is a curve above the x-axis as it is shown. Let the area covered by the graph x-axis, the lines x equals to a and x equal to b, be a. Now divide this shaded area into n rectangles of width h each. You can see in the graph how the area is getting divided. Now these are not exactly rectangles but can be approximated to as h tends to 0 and n tends to infinity. Therefore, the area A equals limit h tending to 0 and n tending to infinity h into f of a plus f of a plus h plus f of a plus 2h up to f of a plus n minus 1 into h, which is equal to limit h tending to 0 and n tending to infinity h into summation r equals to 0 to n minus 1 f of a plus rh. Note that here h is nothing but b minus a divided by n. Therefore, limit n tends to infinity b minus a divided by n into summation r equals to 0 to n minus 1 f of a plus rh, which is equal to integration a to b fx dx equals f of b minus f of a. Thus, we have the area A equals integration a to b fx dx, which is equal to f of b minus f of a, that is equal to b minus a divided by n into limit n tending to infinity summation r equals to 0 to n minus 1 f of a plus rh. Let's take an example. Find integration 0 to 2 x square plus 1 dx as the sum of a limit. Solution. We know that integration a to b fx dx equals b minus a into limit n tending to infinity 1 by n into f of a plus f of h up to f of a plus n minus 1 h, where n is equal to b minus a by h, so h is equal to b minus a by n. Here b is given to be equal to 2 and a equals 0. So b minus a equals 2 and h is equal to 2 by n. Now putting this in the equation, we get integration 0 to 2 x square plus 1 dx equals 2 into limit n tending to infinity 1 by n into f of 0 plus f of 2 by n plus f of 4 by n up to f of 2 into n minus 1 divided by n, which is equal to 2 into limit n tending to infinity 1 by n into 1 plus 2 square by n square plus 1 plus 4 square by n square plus 1 up to 2n minus 2 whole square divided by n square plus 1. Now this is equal to 2 into limit n tending to infinity 1 by n into n plus 1 by n square into 2 square plus 4 square up to 2n minus 2 whole square. Now you can understand here we had done nothing but taken 1 by n square common. And the n which you are seeing is nothing but adding all the ones which were present in the previous equation. So now taking 2 square common, we get 2 into limit n tending to infinity 1 by n into n plus 2 square by n square into 1 square plus 2 square up to n minus 1 whole square. Now using the formula of GP series, we get 2 into limit n tending to infinity 1 by n into n plus 2 square by n square into n minus 1 into n into 2n minus 1 divided by 6 comes out to be 2 into limit n tending to infinity 1 plus 2 by 3 into 1 minus 1 by n into 2 minus 1 by n. Now as n tends to infinity, 1 by n tends to 0. So the equation becomes 2 into 1 plus 4 by 3, that is equal to 14 by 3. Let's take an example. I equals integration 1 by e to e log x dx. Taking constant function 1 as the first function and integrating by parts, we get I equals x log x minus x with the limits 1 by e to e, which is equal to 2 by e. Note that integration a to b fx dx is equal to the magnitude of area bounded by the curve and the x-axis between a and b. Only when the curve does not intersect x-axis at any point between a and b. Note that integration a to b fx dx is equal to the magnitude of area bounded by the curve and the x-axis between a and b. Only when the curve does not intersect x-axis at any point between a and b. Let us take an example. Calculate the area bounded by fx equals to log x and the x-axis between x equals to 1 by e and x equal to e. Solution. First of all, we must find if fx equals to 0 for any value of x belonging to 1 by e to e. So, putting log x equals to 0, we get x equal to 1. Now clearly 1 belongs to the open interval 1 by e to e. You can note the graph of the function. The required area is shaded. If we want to calculate the area, we have to calculate it separately from x equals to 1 by e to x equals to 1 and then from x equals to 1 to x equals to e. Therefore, the area A equals mod of integration 1 by e to 1 log x dx plus integration 1 to e log x dx. Note that fx must be continuous in the open interval a comma b if we have to calculate the definite integral in this region. If integration a to b fx dx equals to 0, then we can conclude that fx equals to 0 must have at least one root provided if f is continuous in open interval a comma b. But the converse is not true. The value of the definite integral of a function over any particular interval depends on the function and the interval, but not on the independent variable of integration. The area A as a function of x equals integration a to b fx dx and is also called the area function. If f be a continuous function on the closed interval a comma b, then let ax be the area function, then a dash x equals fx for all x belonging to the closed interval a comma b. Integration a to b fx dx equals f of x with the limits a to b, that is equal to f of b minus f of a. There is no need to put the constant of integration in calculation of definite integral. We have to take the area, so positive value is required. Therefore, in this example, we had taken modulus. Note that activity. Find the integration of 1 to root 3 dx divided by x square plus 1. You have to select the correct option from the following 4 given options. That's wrong. That's wrong. That's wrong. That's correct.